Hello, pre-algebra. Mr. Lawrence here with your flipped lesson for tonight. It is on probability. And I know some of you think of probability as the chance something can happen. That is a good general definition. I like to think of it more formally. Probability is a fraction, and that fraction is the success of something happening over the total number of possible outcomes. Okay, so let's think about this really basically. Let's say we had a die, and my die happens to be blue, and we want to know the probability of rolling a 6 on this 6-sided die. Well, how many total outcomes are there? There's 6. You could get a 1, a 2, a 3, a 4, a 5, or a 6. Now, if this were a game and you won only if you rolled a 6, you ever been playing in a board game and you get down to the end and you need a 6 to win? All right. Well, how many ways can you roll a 6 on this 6-sided die? Well, there's only one. So the probability would be 1 out of 6. What does that mean? That means that you should expect to get a 6 1 out of every 6 times. Oh, look, I got a 5. I lost. Here, let's write down my outcomes and let's see what happens. I got a 5. All right. Let's spin it again. It's spinning kind of lagging. There we go. There I got a 6. Hey, I won. Yay for me. All right. So I got a 6. And let's see here. Oh, I got a 5. Okay. And there we have a 2. Let me get that spinning again. Spin! All right, I got a 2 and a 1. There's a 2 and a 1. And I got one more spin coming. And this time it's a 3. So my outcome, it ended up like I expected them to. In fact, it would have been perfect if one of these 5s had been a 4, because the law of probability says that each number has a likely chance of happening. So you would expect if I roll it 6 times, that one time I get a 1, one time I get a 2, one time I get a 3, one time I get a 4, 5, and then a 6. All right. Now, the law of probability does not have to be obeyed in the short term. In the long term, it will. If I were to roll this die, say 6 to the 300th power times, a large number, the fractions that I would get, say like 6s, I put the number of 6s I get over the total number of spins, that would reduce or simplify to a fraction, if not 1/6 on the nose, something that is so close you really can't tell the difference. All right, think about that in terms of decimals. All right, 1/6 is, as a decimal, 0.16, and then the 6 repeats. Okay, if I rolled this, say, 6 to the 300th power times, humongous number, I'm not even going to put it in a calculator, it's going to be huge. I would expect that the number of 6s I got divided by this would be this decimal. And you know what? If I do it, if I roll that die enough times, I would get that. Okay? That's probability, the success of something happening over the total number of outcomes. Let's say you have a bag of letters. All right? You got a bag of letters. And the bag is marked Abkadeki Jekyll Monophus Tufersis. Let me spell that for you. Abkadef. Oop, not so strange looking letter there. Hold on. Let me get back to my drawing. Abkadef Jekyll Monop. Because stew versus. Yeah, so that's what the bag is marked. Okay, Abkadeki Jekyll Monopus Tufersis. And you are faced with a challenge. you are playing a game and you know that you can win the game by drawing out a vowel. We want to know how likely it is you're going to get a vowel. Well, first of all, there's 26 letters in this bag, A through Z, right? 26 letters. How many total outcomes are there? Well, there's 26 possibilities. You might draw an A, you might draw a B, you might draw a Q. There's 26 different outcomes. Now, how many vowels are there? Well, typically speaking, there's only 5. A, E, I, O, U. They say sometimes Y, but we're just going to count A, E, I, O, and U. You get any one of those vowels to come out of that bag, you win. Well, that would be a success. So the probability of that happening would be 5 out of 26. All right. What would be the probability of getting a consonant? I don't think I spelled that right. Hold on one second. There we go. That looks a little bit better. Well, we know there are still 26 total outcomes, right? And if there are 5 vowels, then there must be 21 consonants. So the probability would be 21 out of 26. Now, I might have to simplify that, but in this case, I know I'm done. So that's probability. Well, let's look at something a little bit more interesting with probability. And let's consider, this time we have a bag of jelly beans. All right. And in this bag of jelly beans, I have 3 blue jelly beans. I have 2 red jelly beans. And I have 1 green jelly bean. And this time we're going to find the probability, first of all, of getting a blue. We're going to find the probability of getting a red. And then we'll find the probability of getting a green. And then we'll do something kind of cool with this. All right. So first of all, remember, probability is success over total outcomes. So how many total outcomes are there? Well, it looks like there's 3 different blues you could pick, 2 different reds, and 1 green. So it looks like there's 6 total outcomes. Now, how many different ways are there to win? Some of you are thinking, well, there's only 1 to get a blue. That's true, but since there are 6 jelly beans in this bag, and 3 of them are blue, you have 3 ways to win. You could win if you pick this jelly bean, or this jelly bean. So you have 3 possible ways to win. And if I simplify that fraction, 3/6, it becomes 1/2. So the probability of getting a blue jelly bean on one reach into the bag without looking is 1/2. All right, now we'll do the probability of getting a red one. We're assuming the bag is full. We're starting from the beginning. So there are 6 jelly beans in the bag. All right, and there are 2 red ones. So the probability of getting a red is 2/6, but that simplifies to 1/3. All right, trust me, it's going to be so much easier to use 1/3 and 1/2 in our figuring than it will be to use 3/6 and 2/6. So that's why I'm simplifying. All right, probability of getting a green at the start. There are 6 jelly beans in the bag. Only one of them is green. The probability is 1/6, which is already reduced. Okay, now let's look at a situation using the same problem. This time, we are going to figure out the probability of getting a blue and getting another blue. And I'm going to tell you, I need to tell you this. It's either with replacement or without replacement. We're going to say with replacement. What that means is, after I draw the first jelly bean out, I put it back in and draw the second. So I'll do it both ways. The probability of getting a blue on the first draw, blue on the second draw, without replacement, and then I'll do it with replacement. Well, I know from my figuring up above that the probability of getting a blue is 1/2. It's really 3/6, but it simplifies to 1/2. And the probability of getting a blue, again, since I put the first one back, is also 1/2. Now, if I was paying attention yesterday, I know that I should be multiplying these together. Okay, so we need to use the fundamental counting principle and multiply these together. Now, I expect you to know how to multiply fractions. You're 8th graders. Okay, you can't get this wrong anymore. 1 times 1 is 1, and 2 times 2 is 4. So the probability of getting a blue the first time and a blue the second time is 1/4, 1 out of 4. We'd expect if we did that experiment 4 times, we should only win once. All right, let's take it again. We'll take the same problem, clone it, except this time we're going to do it without replacement. And so I'm going to change that to without. What that means is I'm not going to put the first jelly bean back. So I've got to stop and think here. The probability of getting the blue one out the first time is 1/2 still. 3 out of 6 is still 1/2. But now, when I go to do the second jelly bean, there is one less jelly bean in the bag. Yeah, one less. So now the probability, there's the way of winning is only 2, and there are only 5 jelly beans in the bag. I'm still going to use the fundamental counting principle to multiply. And if you understand how fractions work, you know that these 2's can cancel out, turning into 1's. 1 times 1 is 1, and then 1 times 5 is 5. So the probability of that happening is only 1 out of 5. It's less likely to happen if you take the blue away, the first blue. And that makes sense because there's one less blue in the bag, right? One less blue you can get the second time. All right, let's try another one. Same scenario. We've got the 3, 2, and the 1. This time, let's do the probability of getting a blue, red, and a green in that order. And we'll say without replacement. Okay. Okay, well, once again, the probability of getting a blue is 1/2, 3 out of 6. But now, one marble is missing. So there's only 5 left in the bag. And how many reds are in there? Well, I think there are 2 reds, right? Yep, sure enough, there are 2 reds. So there are 2 reds. Now the green, there's only 1 green. But since I've taken the blue out and the red out, now the probability of green is only 1 out of 4. And I'm going to use the fundamental counting principle to multiply these together. Again, I can cancel those 2's. The numerator becomes 1 times 1 times 1, which is 1. 1 times 5 times 4 is 20. 1 out of 20. All right, I want to look at another example here, and then we will let you go. Let's bring our die back. Oh, I'm sorry. Let's think about a deck. No, let's bring our die back. Okay, let's see here. Let's get this blue die out here, and let's get this green die out here. Okay. And we want to know the probability of getting an even number on the blue die and a number less than 3 on the green die. How often should that occur? How likely is that to occur? Well, let's stop and think here. The probability of an even number on the blue die. Well, the even numbers are what? 2, 4, and 6. So there's 3 of them. And there are a total of 6 possible outcomes. 3, 6, which I again can reduce to 1/2. Now on the green die, I need a number that is less than 3. Well, there's a 1, and there's also a 2. So that will be 2 of them out of 6, which simplifies to 1/3. So I will do 1/2 times 1/3 and get 1/6. So the probability of this happening is 1 out of 6. All right. Very good. This stuff should be pretty easy. Just tape it simple. All right, Mr. Lawrence signing off. Have a good night, everybody.